Greetings, friend, and welcome. Everyone's talking about machine learning. But let's be honest, most people have no idea what it actually means. It's the tech behind AI, self-driving cars, ChatGPT, your YouTube feed, even what shows up in your email. But how does it really work? It's not magic, it's math. And once you see behind the curtain, you'll understand why machine learning is already running your life and what's coming next. At its core, machine learning is about teaching computers to learn patterns without being explicitly programmed. Instead of writing a rule like, if X happens, do Y, you give the machine data, and it figures out the pattern on its own. It's kind of like training a dog, not by giving it commands, but by showing it 10,000 examples of good and bad behavior until it learns what works. This idea dates back to the 1950s, but it wasn't until the last decade that we had enough data and computing power to make it dangerous, in both the good and bad sense. Let's make this real. Take YouTube, maybe where you're watching this right now. The algorithm doesn't just suggest videos based on what you've watched. It tracks how long you watched, where you paused, what you skipped, and what you clicked next. Then it learns what type of videos you watch, what your habits are, and feeds you more of that. That's machine learning. It didn't ask a human to write the rules. It found the patterns in billions of views. It's not using logic, it's using math and using this to optimize for one thing, your attention. But here's the catch. You end up in a feedback loop. Everything you watch trains the system to show you more of the same, which means your world narrows one click at a time. You receive fewer new perspectives, less randomness, less education and challenge. Only a highly personalized bubble built entirely by your past behavior. And it's not just YouTube. Spotify, Instagram, TikTok, they all use similar models. You're not choosing content anymore. You're training the machine on what to show you next. And that might mean less exposure to new ideas, fewer opposing views, or even truth that doesn't perform. This is how algorithms become echo chambers. Not by design, but by optimization. However, there are three main types of machine learning. 1. Supervised learning. You give it labeled data. Example. Email spam filters. You show it thousands of spam and non-spam emails, and it learns what spam looks like. 2. Unsupervised learning. No labels. The machine finds patterns by itself. Example. Customer segmentation. Retailers like Amazon use this to group you based on behavior, even if you've never said a word. 3. Reinforcement learning. The system learns by trial and error. Think self-driving cars, robotics, even AlphaGo beating the world's best player. It tries something, gets feedback, and learns to optimize just like we do. But here's where it gets messy. In 2018, Amazon scrapped an internal AI recruiting tool. Why? Because it learned from historical hiring data that Amazon had a bias toward hiring men. So it started downgrading resumes that included women's terms, like women's chess club and even women's colleges. It wasn't evil, it was learning from biased data. But the result was discriminatory. And it's not just Amazon. In 2020, a study found that a healthcare algorithm in the US was systematically underestimating the medical needs of Black patients. Why? Because historical data showed they received less treatment, so the AI assumed they needed less care. It learned from biased systems and quietly reinforced them. Machine learning does exactly what you teach it, even if what you're teaching is broken. Now let's talk about something more recent, ChatGPT. ChatGPT is built on a machine learning architecture called a transformer, specifically a large language model. It was trained on huge amounts of text from books, websites, articles, basically the internet. It doesn't understand, meaning the way humans do. It's just code. Transformers work by paying attention to the context of words in a sentence and predicting what comes next. It's like this. You say, once upon a, and it guesses time. Then it keeps going, predicting the next word over and over, using everything it's seen before. But what makes transformers powerful is that they don't just look at the last few words. They analyze entire paragraphs at once. They build contextual relationships. So they know that if you're talking about science, the word cell means something different than if you're talking about prisons. So when ChatGPT gives you a response, it's not thinking, it's not conscious, it's just math, predicting one word at a time, based on probabilities drawn from trillions of examples. What's the most likely next word based on everything it's seen before? When you ask it a question, it's not searching for a fact, it's completing a sentence based on probability. In its own way, it mirrors how we respond to each other online. Algorithms, just like us, get better at guessing what's safe to say based on what's been said before. That's how machine learning shapes conversations, opinions, and even personality. The more it adapts to us, the more we adapt to it. Machine learning is powerful, but also fragile. It can be fooled, hacked, or biased, and most people wouldn't even know. There are AI models that can be tricked into thinking a stop sign is a toaster. Medical AI that misdiagnoses certain populations. In fact, one AI model used to predict patient outcomes was 40% less accurate for minority groups. Not because of bad code, but because the data it was trained on had gaps. When historical data is incomplete or biased, the future it builds will be too. Financial models that reinforce inequality. And here's the scary part. The smarter it gets, the less we understand how it works. Even the engineers building them don't always know why a model made a certain decision. It's a black box. But here's the real question. Where is machine learning going next? We're not just training AI to respond, we're teaching it to make decisions, write code, trade stocks, and even generate art, music, and video. In 2024, OpenAI released Sora, a text-to-video model that can generate realistic video clips from just a few sentences. We're talking cinematic-level footage, made with no camera at all. And tools like Devin, the AI software engineer, can already write and deploy working code with minimal input. That's not theoretical. Startups are already using Devin to replace junior devs, and it's working. In healthcare, models like Google's MedPalm are outperforming some doctors on diagnostic tasks. In finance, AIs are analyzing markets faster than any team of humans ever could. The next wave is autonomy. Models that make decisions, act in the world, and optimize goals without waiting for human instructions. And here's the thing. These systems don't have emotions. They don't have ethics. They don't have context outside what we give them. So the future of machine learning isn't just about what it can do. It's about who's building it, what values we train it with, and whether we'll be allowed to question the answers it gives us. So how does machine learning actually work? It works by finding patterns. From data, from us, it reflects who we are, for better and for worse. It powers your music, your maps, your search results, even this video. And in the future, it might be making decisions that affect your job, your freedom, and your health. So maybe it's time we stop calling it magic and start understanding the system running the world. Like all powerful tools, it's not about whether it's good or bad, it's about how we use it, who controls it, and who it's learning from. This is the Singularity Hub, your gateway to tomorrow's tech. Subscribe now and stay aware.